Hi, it's Gradyn Grobe with Clark Welding and Fabricating. I'm here in Las Vegas, Nevada with a new boiler install. These are two Hurst Series 400, 350 horsepower boilers. They're running high pressure steam, 150 pound design. They have a Hurst package with Oilon burner, Siemens controls. We've integrated the entire plant together, so the communication is great. Got a lot of cool controls on this system. We're gonna go over it today. So first, let's start on the burner. This is an Oilon burner. They're headquartered in Finland, but they have a facility in Thomasville, Georgia, so they're locally available. A really high efficiency burner. This unit is dual fuel with an FGR coming in to get down to 20 ppm NOx. That was the requirement on this job, and we were able to achieve that no problem. These Oilon units use a Siemens LMV52. This unit has a 6-inch touchscreen on it, so you have a little bit better visual when you're adjusting the controls. We've got a VFD here. It comes on this unit, and then you can't see it, but up in the stack outside of the building, we've got an O2 trim sensor plugged in, so we can really tune this burner efficiently. We'll walk around here, we'll see our natural gas train. Just to have a little bit more feedback, we've put a natural gas flow meter in line so that you can read how much fuel you're consuming. And then our number 2 oil enters into the burner here. That gives you a backup fuel option in case your natural gas goes down. When we put this package together, it was specified that we use flange connections, so you'll see quite a few flanges on this boiler. We use a Siemens differential pressure transmitter controlled through a Siemens RWF5. That is going to control your water level in the unit at all times. That pairs with a primary low water cutoff. This is a McDonnell Miller 157. See an armored gauge glass next to that. It's just a little bit more durable. Your secondary low water cutoff is a McDonnell Miller 150. In addition to that, we've got a high water level alarm here. It's a McDonnell Miller 150. This job was specified with float level controls for every circumstance, so that's what we did. All right, I want to show you guys how the water enters the boiler. So this unit has a Hurst Stackmaster economizer, and as the water enters into the system, it goes through the economizer. That heats the water up around 240 degrees before it enters into the unit. For more precise measurement, we have inlet sensors on the water side and the air side, so you know exactly how efficient your unit's going, and you know exactly how many BTUs you're getting into your feed water before it goes into the unit. We've got a modulating control. This is a Schubert-Sulzer modulating motor that's controlled by the Siemens DP transmitter that we had on the other side of the boiler. 3-valve bypass, again all flanged, and then it enters into the boiler here. So for code, we have 2 quick and 1 slow bottom blowdown valve. The connections are here, and they meet in the middle at a common drain that goes towards your blowdown separator on the other side of the room. Yeah, so one other control we want to touch on is the low fire hold. This is a Siemens sensor that's plugged into the belly of the boiler, and that way you can measure your temperature and make sure your boiler's staying warm. Also on this unit, we've got an access ladder and platform that was built at the factory. You see here where the brackets are already pre-assembled. So whenever you get the unit, you just bolt it on and it's ready to go. So for supplying feed water to these boilers, we've got a really interesting setup here. Got a 30,000 pound an hour spray type deaerator from Hurst Boiler. We've got a vertical 600 gallon stainless surge tank from Hurst Boiler as well. This unit has a Siemens control system that monitors both units. We've got 3 feed water pumps from the deaerator, 2 feed water pumps from the surge tank. You've got N+1 redundancy with the feed water pumps. You've got primary and backup on the surge side. They're piped commonly so that in the case of a failure on this DA, you can run the transfer pumps directly over to this DA, supply these feed water pumps, and they will use their force to get water into those boilers and run them in an emergency situation. So here we have the control system for the DA and surge. The monitoring here is only possible because we have sensors placed in the unit to measure temperature, pressure. We've got another differential pressure transmitter from Siemens. That controls the modulating valve that moves water into this DA and keeps it at a set level. You also can see your feed water set pressure along with the current operating pressure to make sure that your pumps are providing what they are supposed to. Right now, they're really running nice and easy. Your Grundfos pumps are actually CREs, so they have integral VFDs built into the pumps. That's a bit unusual to pair that with the touchscreen system from Siemens, but it does work. It was specified by the customer and that's the way they wanted it, so we put it together and it works like a champ. So just like you had on the DA, we've got a Siemens differential pressure transmitter that's giving a measurement over to this modulating makeup valve, and that's keeping your water level consistent in that surge tank. We've also got sensors for transfer pump pressure, and that's controlling through the touchscreen over on the other end. That's controlling these integral VFD pumps from Grundfos. Those are the CRE series. They're sized appropriately to get that water from the surge tank over to the DA and have it ready to be supplied into the boiler. All right, to kind of tie all these systems together, we have a Siemens 10-inch master panel. This receives Modbus signals from both boilers, and it receives a Modbus signal from the DA surge panel that we looked at earlier. It all marries it together into one unit. Then from there, it converts that Modbus signal to BACnet, which is what this building required from our controls.